Greetings to dear students. So this is the last problem in the section Cauchy's theorem and Cauchy's integral formula. Okay, this problem is same as the previous problem. Okay, so let us see how we have to do find the we have to evaluate this integral value of this. So the given integral is integral over c z by 9 minus z square into z plus I, where c is the circle, modulus of z equal to 2. Okay, so here 9 minus z square, it's not a linear fraction, it's not a linear equation. So we are making into the linear, converting into the linear equation. So 9 minus z square can be written as 3 minus z into 3 plus z, isn't it? So 9 minus z square can be written as 3 plus z into 3 minus z. So note that the circle given as modulus of z equal to 2. Okay, so circle given as modulus of z equal to 2. That is, it is a circle with the center 0 and radius 2. A circle with the, so 1 minute. This is a circle. Okay, this is y-axis and this is x-axis, and it is the circle, our simple closed curve with the center 0 and radius 2. Okay, so therefore this is 2 and this is minus 2. Okay, so this is 2 and this is minus 2. Here the point, what are the points the analytic fails? 3, minus 3 and minus I. Okay, so 3 lies where? Outside the circle. 3 lies somewhere here and minus 3 lies here. So these are the points 3 and minus 3 are lies outside the circle. The point minus I is nothing but minus I is equal to 0 comma minus 1, isn't it? Minus I is 0 comma minus 1. It lies here. Sorry, it lies here. 0 comma minus 1 is lies here. It is lies inside the circle, isn't it? So therefore, the 2 points which lies outside the circle, 3 and minus 3. So therefore, the functions 9 minus z square can be taken into f of z. So here, if the numerator part has only z, since the points 3 and minus 3 lies outside the circles, I am taking 9 minus z square into the numerator part. So therefore our okay, so therefore our integral becomes, the given integral becomes is the integral over c z by is 9 minus z square into z plus I dz is equal to 9 by is sorry z by 9 minus z square, because since the 2 points lies outside, we are taking this into the numerator part. Z by 9 minus z square divided by z plus I dz. So therefore now our f of z is z by 9 minus z square. Since the point minus I lies inside the circle, by Cauchy's integral formula, integral over this is equal to 2 pi I into f of minus I. What is f of z? Z by 9 minus z square. So substitute the value of minus I in the place of z, we get minus I by 9 minus I square. So minus I by 9, as I square is equal to minus 1, we get minus I square is equal to minus 1. So the value of this integral is pi by 5. Okay, value of this integral is pi by 5. That is integral over c z by 9 minus z square into z plus pi z plus I dz is equal to pi by 5. Okay, this is the shortest method. Or else what you have to do, you have to split this into 3 parts. You have to split these 3 into 3 equations. Sorry, 3 three parts by partial fraction. Then again you have to evaluate the integral one by one, and you have to check whether this point lies inside or outside, whether you have to apply Cauchy's theorem or Cauchy's integral formula, and these things. Okay, but instead of doing the partial fraction, you can directly apply Cauchy's integral formula by taking 9 minus z square into the numerator part. Okay, so if I these kinds of sum is given for your exam or for given you means, you have to check whether all these points lies inside the circles. If all these points inside the circle means, definitely you have to do the partial fraction, because all these points lies inside the circle. If some of the points lies outside the circle means, outside the curve means, though which are the points lies outside, you have to take that equation into the numerator part, and you have to change the f given f of z into some other. Okay, so here f of z as z, by taking 9 minus z square in the numerator part, we change the f of z as z by 9 minus z square. Okay, so whichever points lies outside, we are taking into the numerator part. Whichever points lies inside the circle, those points will remain in the denominator part. If you have two product of, if the denominator part has product of two linear equation, then you have to do the partial fraction. Okay, so these are the things you have to remember when you have to evaluate the integral using Cauchy's theorem and Cauchy's integral formula. So I hope you get an idea to evaluate the integral using Cauchy's and integral formula. Yeah, thank you, dear students. Thank you.